Hey guys, welcome to this example video on properties of logarithms. So in this video, I'm going to show you 5 different examples of just writing an expression as a single logarithm. And I'm using a slightly different format in this example video. I'm hoping that it makes it a little bit easier to determine what examples you might want to see. So here's the list of examples that I have. If you're looking to see just a particular example, I have just timestamps in the description of this video, but I've also labeled each one kind of as you go through. So hopefully if you just try to scrub through the video, it's a little bit easier to. Now, you could help me out by letting me know if you liked this format, because that will help me determine if I want to make more videos like this in the future. So just kind of keep it in mind as we go through this. Okay, so these are the 5 examples that I'm going to cover. So you can also use this video as a way to kind of quiz yourself, try all the examples, and then you can take a look at the solutions kind of in each video part. So without further ado, let's get started. Okay, so starting with this first example, so I can begin by rewriting each part using the power rule as shown. So first I've just rewritten these so that each part has its exponent. Now, if this is like totally not something that you know anything about, I do have a video where I explain all of the properties of logarithms in detail. So I am assuming that you kind of understand this, and if not, then I've got another video you can go and watch. So notice that everything is being added together, which would mean that you can actually just rewrite everything using multiplication. So this will just be log of x to the third, y, z squared, and you're done. Okay, so moving on to this next one. So now this is really a matter of understanding what it means to have a plus sign or a minus sign in front of the logarithm. So let's see. These parts are going to go in the denominator, and this part's going to go in the numerator. And then this 2 is going to end up on top of the y. So maybe first I'll start by just getting rid of the 2. So I'll rewrite this so that this is an exponent. So this now becomes y squared. And now, like I said, so if you have a minus sign, you end up in the denominator. So this will be log base 3 of x over y squared z. And you know that because both of these parts have the negative in front of them. So every time they have a negative, it automatically goes in the denominator. So you can kind of rely on that. So moving on to this one. So this one is like just one basic rule that you're using, but there's a little twist once you kind of use that rule. So I can rewrite this as a single logarithm just using division, but sometimes what's going to happen when you do this is that you can simplify farther. So you can tell that you can actually rewrite x squared minus 4. You can factor that. So this will be now x minus 2, and then I've got x plus 2 and x minus 2. So those x minus 2's drop out. So this will be log of 1 over x plus 2, so that would be the final answer there. So if you can simplify farther, you should go ahead and try to do that. Okay, so moving on to D here. So very similar to kind of the previous one. So if you've got a plus sign, you're going to end up on top. If you've got a minus sign, you're going to end up in the bottom. So first, if I rewrite all of these just with their exponents first, so I will have this. Now, here's the one weird thing that kind of happens here. What do you do with that 6? So you're actually going to want to rewrite this so that it's x squared, all of that, to the 6. And so then you're also going to have to use a logarithm. You're going to have to use a exponential rules. Oh my gosh, I don't know what I was thinking. So, all right, so I've got to multiply these two things together. So let me actually go ahead and do that just to make this a little bit easier to look at. So of log base 2 of y to the 5th, and then minus log base x to the 12th. Okay, so now I can go ahead and write these two parts on top and this part in the bottom. So my single logarithm will look like this. So I have log base 2 of x to the 3rd, y to the 5th, over x to the 12th. And like I said, so sometimes you can actually simplify these farther. So now we actually want to do that. So the final way that I can write this will be, I've got y to the 5th over x to the 9th. That will be how that simplifies. And now for this final one. So now I've got just some funkier looking exponents here. So first, if I rewrite this with its exponential form, so I can, well, not exponential form, but just rewrite this with exponents. So I can rewrite this as x to the 1/2, and then this will be log base 3 of y to the 3/2. Okay, so now you might actually want to think about what does it mean to have these like half powers. So these are both actually square roots. So if I wanted to rewrite these using square roots, it would be log base 3 of the square root of x. And then now be careful with this one, right? So I just want to get the square root part of this. So this would be log base 3. I've got the square root of y cubed. So that would be how I could break that up. So I still got the top exponent that just stays here, but now I've at least represented this with a square root. And now you'll see why I'm doing this. So when I actually use my property of a logarithm, so now I can rewrite both of these with a square root. And using properties of square roots, I can actually multiply these two things together so that they're just under one singular square root. So this would be the most simplified form of this particular expression. Okay, so if you found that helpful, consider maybe giving my video a like or subscribing to my channel, or even better, share it with a friend. I'm trying to put as much free math on the internet as possible, so every little bit helps. And that covers that video. I have lots of other videos on logarithms, though, if you'd like to see them. So hopefully I'll see you guys next time. Thanks for watching.